Hi, hello. Today in our video we will see trees and its basic terminologies. Okay, first of all, tree. What is tree? Tree is a non-linear data structure which is represented in a hierarchical way. So we will see with one example. So if we want to show hierarchical representation of any organization or any college, we can say if you take college, the principal come first. Principal. Okay, under the principal we say there are many departments, so there will be HODs. So HODs. Again under the HODs there will be senior faculties. Senior faculty. Under this senior faculties again having junior faculties. Junior faculties. See, this is a hierarchical representation of a college. Again many more will come, but I am showing a simply 4 level. Okay, here the principal will be the main. Again 3 HODs will be reporting to principal. Again senior faculties will be reporting to the HODs and junior faculties will be reporting to the senior faculty. So see this structure. Closely looking this structure, we will come to know it is a inverse structure of our real tree. How it is looking? It is looking like a inverse structure of a tree. See here, what comes first? Here principal. So what will be first here? It is root. So the first element in the tree is a root. I will explain once again later. The first element in the principal is tree. So whatever comes in the last, that is leaves. So these are all called leaf. Okay. Similarly, there are many branches. So these are what? Branches. They are linked. HODs are linked to principal. SF is also linked to HOD and also principal, but not directly through HOD. So these are all branches. So these are all branches, nothing but edges, links. Okay. So this hierarchical structure, it represents the inverse tree. So the name tree has come to this data structure. So we will take one other example and explain. See here. So 1 2 3 1 2 3 4 5 6 7 8 9. See here, this is our tree. So each and every node is contains some data which is connected through these links called edges here. So tree is the data structure defined as collection of elements or entities which are called as nodes and represented in a hierarchical way. and represent in a hierarchy. So tree is a collection of elements or a data which is linked. Tree is a collection of data or elements which are called as nodes, which are linked to one another through edges and represented in a hierarchical way. So here principle is a what? This node is a first, you consider this node is a first node. So this is a contains a principle here. So these are all HOD. So this node may contain their names or their details. This may contain the details of HODs. Say like this, we can represent each and every element in a tree data structure. So we will see some basic terminologies in the tree now. One by one we will see the basic terminologies in a tree. For that we will take one diagram. One, two, three, 4, 5, 6, 7, 8, 9, 10, 11. Okay, see, this is one tree. So we will see one by one the terminologies in trees. First one is root. First one is root. What is root? Root is a first node in a tree. First node in a tree, or a tree which don't have any parent. The tree which don't have any parent. First node in a tree, or node that don't have parent, that is called as root. The first node or the root or node that don't have parent is called as root node. So this is root node. One is a root node in this example. Okay, next we'll see edge. Edge. What is edge? What is edge? The connection or a link. The connection or a link between the two nodes. Here what are nodes? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. These all are nodes. So 1 and 2, how they are connected? They are connected with this link. So 1 and 3 are also connected with this link. So these are the links connected to two nodes or more nodes. So this link is called as edge. So edge is the link or connection between two nodes. Connection between two nodes. Okay, next is parent node. Next is a parent node. Okay, if any node contains a subnode, then that node is said to be parent of that subnode. See here. So 2 and 3 are subnodes of 1. So 2 and 3 are subnodes of 1. So what is our definition? If the node contains a subnode, then node is a parent of that subnode. See, 1 contains a subnode, 2 and 3. So 1 will become automatically a parent of which node? Their subnodes. So where their subnode is 2 and 3. So 1 is a parent of 2 and 3. Similarly, 2 has a subnodes 4 and 5. 3 also have subnodes 6 and 7. So 4 and 5 are 2 is a parent of 4 and 5. Similarly, 3 is a parent of 6 and 7. So this is a parent. Next, a child node. Here also the same. If a node contains or if a node is descendant of any node, if nodes is a descendant of any node, then that node is a child node. See here, 2 and 3 are descendants because it is a descendant of 1. So 2 and 3 are a child node. Similarly, 4 and 5 are also descendants of 2. 6 and 7 are descendants of 3. So 4, 5, 6, 7 all are child node. Similarly, 8 is descendant of 4, 9 and 10 is descendant of 5, 11 is descendant of 7. So these 4 also a child node. See here, 1, is this descendant of any node? No. So it is not a child node. Okay. If the node is a descendant of any other node, then that node is called as a child node. Okay. Next, sibling. What are siblings? Siblings, a node which share a same parent. The node which share a same parent. Nodes having a same parent is known as sibling. See here, 2 and 3 are having a same parent, 1. So 2 and 3 are siblings. 4 and 5 share same parent, that is 2. So 2, 4 and 5 are siblings. 6 and 7 also share same parent. So 6 and 7 is also a siblings. 8, okay, 8's don't have any sharing parent, so there are no siblings. So 9 and 10 share same parent. So these two are called as siblings. Okay, if 2 or more nodes are said to be siblings if they share a same parent. If they are children of a same parent, then that node are called as siblings. If nodes share a same parent, then that nodes are called sibling. Okay. Next, leaf node. Next one is leaf node. What is leaf node? Leaf node. So the node which don't have any children. Such nodes are called as leaf nodes. In our example, C6. So come from first. 1 have 2 children, 2 and 3. So it is not a leaf node. 2 have 4 and 5. So 2 is also not. 4 is having 8 as a child. So it is not a 4 is not a leaf node. 5 also having children. So it is also not leaf node. Come to 6. Whether 6 has any nodes or children? 6 don't have any children. So 6 is our leaf node. Come to 7. 7 is having a 7 as a child. So 7 is not a leaf node. Next 8. 8 is having any children? No. 9 is having any children? No. 10 is having any children? No. So 9, 8, 9, 10 and 11 is also not having any children. So 8, 9, 10, 11. 9, 10, 11. These are a leaf node. The nodes which don't have any children or child is known as leaf node. The node which don't have any child is called leaf node. Okay. Next, internal nodes. What is internal nodes? A node has at least one child. If a node has at least one child node, then that nodes are called as internal nodes. I will drop the upper part. Internal node. Node which have a child node which have a child is called internal node. See here, 2 and 3 have child, 4 and 5, 6, 7. Node sort 6 is the internal child, 7 is having child, so 7 is internal node, 5 is having child, 4 is also having child. These are internal nodes. 8 is not having child, 9 is also not having, so these are all not internal child. Even 6 also is not having child, so it is also not an internal child. Next, depth of a node. Next, depth of a node. What is the depth of a node? See, if we want to find the depth of a node, so if I want to find a depth of 5, so the distance or the path from this node, the length of a path from the node to the root is known as depth of that node. So if I want to check the depth of node 5, then the path is from here to here, 1, here to here, 2. So 2 is the depth of a node 5. 2 is depth of node 5. So it is a length of a path. This is a path. The length of this path from the node to the root node is called depth of the node. Similarly, if we want to find the depth of node 9, so we have to calculate the length of a path. So 1 here, from here to here 2, from here to here it is 3. So we have to find the paths to the root first, and that length will be the depth of a node. So depth of 9 is 3. So the depth of a node is the length of a path from node to the root node. To the root node, that is called as depth of a node. Next is height of a node. Next is height of a node. So here a slight difference between depth of a node and height of. Here it is also a length of a path from node to leaf node, but here we will take the longest path. The longest path from the node to the leaf node is known as height of a node. So here take for example, if I want to find height of a tree, if I want to find height of tree, there are two paths to the tree. I have to this node we have two paths, that is one from 6 to 3, that is 1, that is 6 to 3, that is length is 1, and another path is 11 to 7 and 7 to 3. So the length of the path is 1 2, that is 2, here 1. So according to our definition, the height of a node is the longest path from leaf node to that node. So here 6 is also leaf node, 11 is also a leaf node. So here two paths from 6 to 3, the length of a path is 1. From 11 to 3, the length of a path is 2. So which is the longest path? So this is our longest path. So the height is considered as 2. So our definition is the longest path from leaf node to a node. Height of a node is the longest path from the leaf node to a node. Okay, these are some basic terminologies. And also here trees, subtree. See here, this is complete whole one tree. See here, this is one tree. Okay, this is also one tree. Here this is also one tree, and this is also one tree. So these are all called subtrees. Completely this is called as left subtree and this is called as right subtree. The tree left to the root node is called as left subtree. Tree right to the root node is called as right subtree. So these are all some terminologies in trees. A tree is a collection of elements or objects called node which are arranged in a hierarchical order or hierarchical manner. So we saw some terminologies in tree, that is root, parent, parent node, child node, and internal nodes, and edges, height of the node, depth of the node, siblings, and so on. So I hope you understood and you like this video. Okay, in our next video we will see the different types of trees. Okay, thank you.